In this lecture, we talk about interference of light waves. Now we can only see interference. So this interference could be constructive or destructive if the sources of light are coherent. So what does coherent mean? So coherent means the sources of light maintain a constant phase difference with respect to each other. So let us see this in a diagram, what constant phase difference means. So first focus on this red curve. So this red curve is nothing but a standard sine curve. So this is, say, sine of t, where t is time and time is varying in this direction. So you can see sine of 0 is 0, sine of pi by 2 is 1, sine of pi is 0, sine of 2 pi is 0, and so on. So this is the standard sine wave. Now we add a constant phase to it. So now we have a blue wave. So this blue wave, you have sine of t plus phi. So this phi you call a constant phase. Constant phase. So once you have added this constant phase, you get a blue wave. So this also looks like a sine wave, but there is a phase difference here. So this phase here is called phi. So difference between this point and this point is phi, and this is the constant phase. So if there is a constant phase, then we can say that these two light waves are coherent. So the blue and the red are coherent. So these two waves are coherent because you have a constant phase between them. Now if the phase angle between the sources continuously changes, so you had a constant phi here, suppose this phi is continuously changing, then we call them incoherent. Now whenever you talk about constructive or destructive interference, that means the source of light waves is coherent. So you can only talk about constructive or destructive interference if you have coherent light waves. If you have incoherent light waves, you do not even know anything about phi because this phi is continuously changing. So you cannot talk about interference. So again, if you want to talk about interference, you are essentially talking about coherent light waves. Now we come to the Young's double slit experiment. So this experiment is very important. So this experiment, what does it do is it establishes that the light wave travels in the waveform. So that is, the light is actually a wave. So we will have two kinds of interference here. We will have constructive interference and destructive interference. So we will come down to these formulas later, but let us see the double slit experiment figuratively. So say you have a light source right here. So there is this big light source. So this is the source of light, and there are two slits. So there is a slit right here which we will mark in blue, and there is a slit right here which we will mark in dark green. So there are two slits. So you have a light source that could be like a sodium bulb, so that you have a monochromatic light source. That means light with a single wavelength. And then this light source, it splits into or goes through two slits. So since we are saying that the light is traveling in a waveform, you have, say, this blue indicating the light coming from slit 1 and this green indicating light coming from slit 2. So these two waves coming from slit 2 and slit 1 could add each other. So for example, say from the slit 2, the wave is coming in this direction. So I will draw this again. From slit 2, the wave is coming in this direction, and from slit 1, the wave is coming in this direction. So we can add these two waves up. So these two waves will add up and there will be constructive interference. that is these two waves add up and you have a white spot corresponding to the two light waves, because these two light waves add up from both the slits. Now suppose you have from one of the slits the light wave is again coming like this, but from the other slit the light wave comes in the opposite direction, that is like this. So now if you add these two light waves, you will just get a 0. They will cancel each other out. So when this is positive, this side is negative, so this will become 0. And similarly here, when this side is negative, this side is positive, these two will add up and become 0. So think of two sine waves but opposite to each other, so they cancel each other out. So this is called destructive interference. So this is, DI stands for destructive interference. So these two light waves from slit 1 and slit 2 have cancelled each other out. So corresponding to this there is a dark band. Then again there will be constructive interference, that is two light waves will add each other because they are in the same direction. Then again you will have a dark band because two light waves have cancelled each other out. Then again you will have this white band because two light waves have added each other. So CI stands for constructive interference, then destructive. You have constructive interference and destructive. So again notice the constructive interference, these two light waves are meeting each other. Here in destructive interference, these two light waves from slit 1 we have blue and dark green from slit 2, their curves are in opposite direction, so they're cancelling each other. So this is essentially the Young's double slit experiment. You have a light or like a light band here, then dark, light, dark, and so on. So this shows that the light is essentially a wave because it adds like a wave, and this light part shows that the two waves are adding up, and here they are in the dark part, they are cancelling each other out. So this could only happen, you have this band, this is only possible if you have light as a wave, then you can add it up and it also cancels. So this is essentially the result of Young's double slit experiment. Now we want to come to this formula. We want to have a formula when there is constructive interference and when there is destructive interference. So let us parse this result. So delta is the path difference. So you have these two slits. So say this is slit 2 and this is slit 1. You have a source of light, and this light source that now goes to slit 2 and slit 1. So say slit 2, this is the viewing screen here. This is the viewing screen on which you have this pattern, yeah, of this dark and light. So you have pick a point P. So from slit 2 there is a ray 2 going from slit 2 to point P, and from slit 1 there is a ray 1 going to point P, and say this angle is theta. You drop a perpendicular from ray 2 to ray 1, you have this angle theta. Then sine theta is equal to opposite side, which is delta, divided by d. D is the difference or the distance between slit 2 and slit 1. So path difference is equal to d sine theta. So again sine theta would be equal to opposite side delta divided by hypotenuse, which is d. So path difference is the difference, delta is nothing but equal to, so you can say one path minus the other path. So this is the difference. So this you can say it is approximately equal to r1 minus r2, not exactly but approximately. So let us put approximate sign here. So this delta will anyway be d sine theta in this case here and also in this case here. So this is always d sine theta. Now in case of constructive interference, this is equal to n times lambda. So lambda is the wavelength of the light source, and in the destructive interference it will be n plus half lambda. Again this means nothing much except that in the constructive case these two light waves from the two slits are kind of matching each other, so they add up. Whereas In the destructive case, these two light waves are opposite to each other. So if this is one light wave, the other one will be exactly opposite to cancel it out. So that is why you have n plus half lambda, and n could be an integer. N could be 0, plus minus 1, or plus or minus 2, or plus or minus 3 in both the cases. That is, n could be any integer. N could be any integer.